Good afternoon. First, I think to begin with, hearing you speak, sitting there, reminded me of one of my professors, who's no more, Professor Tredibroy Chaudhary, excellent man, who used to tell us, when we talk about distributed databases in general, as developers, we look at them with a sense of morality. He used to requote Lamport and tell us that it's not a moral question, that you should not be asking, hey, are you distributed in a sense of moral view to not to judge it, but more like a narrative and existentialist way to understand how the distributed database functions and then probably what you can get of it. He used to, I think, in one line sort of mix Nietzsche and Lamport and sort of mentored us into thinking about distributed databases. So a huge shout out to him. Hearing you speak kind of reminded me of him sitting there. Thank you very much for that. His guru, I am Koushik. We are from PhonePe. Also, I kind of figured sitting there that we missed an agenda slide. That's all right. I think this is probably as good as we can get to agenda. As opposed to general setups that you've seen so far, we are an on-prem shop. And over the course of next 30 minutes, I'm going to take you through a bunch of our use cases and then talk about it at the point of a DBA, right? A site reliability engineer, how he looks at any database, not let alone Aerospike. And along the journey, we'll talk about our scale. And a couple of years ago at the Aerospike Summit, we spoke about our data models. We spoke about our different usage patterns. So I'll keep that to a minimum. You can always rehash that from the older presentation, and I'll try and see if we can talk a lot about scale this time around. Audible, right? Or do I have to be a little louder than this? This is good? Brilliant. This is the customary introduce PhonePe. Like, we started out as a utilitarian app in 2016, September 8th, I think, was our launch date, if I remember correctly. A direction at the channel that we wanted to sort of grow upon has kind of been consistent, right? Along these matrices, send, spend, manage, and grow. What we really mean by that is, to kind of have 1 billion people start to get onto digital payments. We've massively helped by, I call it the geo effect, truthfully so. It's made internet available for everybody. And UPI has helped incredibly, and we've played a stupendous role in the journey of India. We started out in 2016 as a utilitarian app where we started with P2P payments. If you guys are the early users of PhonePe, you'd remember we had a recharge bill pay shop and just about P2P payments. From there, now on the second half of our journey, we're trying to sort of manage your wealth and probably create wealth for everybody in the country. To move forward, this is our story in numbers. At the moment, by the time I'm finishing this slide, these numbers may change. That's how fast we are growing, really. Last time I checked, which was about a couple of weeks ago, there are about 380 million registered users, 170 million MAU, 6 billion app opens across Android and iOS. We have done about 3 billion total transactions with a 100 million transactions run rate per day and $800 billion of annualized TPV with 21,000 billers live. That's an important one. We are an integration heavy company. Right? We are an app of app. We are a super app. We work with a bunch of vendors, banks to service providers to whatnot. And we have about 30 million merchants on our platform, both offline and online. That's kind of our scale, and this is the scale we operate in. And when we started really setting up, right, there were a few guiding principles that we sort of set up for ourselves. First thing was, I'll kind of give a second, probably let you guys internalize the numbers. This is what we do on a day-to-day basis or per second. And these might have grown by the time I finished this. Right? When we started up, right, we wanted to be lean, not lean in terms of just the number of employees you have or lean in terms of choices, but lean in terms of also tech stack. Because we're an on-prem shop, we did not want to have everybody have everything on the ground because from a point of view of a site reliability engineer, for you to manage, we're a heavily SRE-driven company. You cannot have 10 heterogeneous data stores or 10 heterogeneous platform components lying around and then build DR for that, build BCP for that, build replication for that, build tooling for that, build anomalies for that. It's virtually impossible. So from get-go, we sort of set this up as a guiding principle for ourselves. And we work with really a handful of data stores. We work with HBase for all of our big data needs, Maria for all of our relational database purposes, Aerospike for pretty much everything else, Elasticsearch for sorters and filters, which hopefully with 6.1 we would move. But that's our setup. One of the other things was horizontal expansion. Obviously, I mean, like, everybody wants to grow linearly, and resource utilization, it's important. You don't want to deploy thousands and thousands of nodes, honestly. It's a management nightmare. We wanted to have a eye on the capacity planning, be predictable about it, right? A footprint of 2,000 nodes to run a million QPS is absolute no-no. I mean, wherever you are, right? And isolation and shared nothing. You want to minimize the chatter between the nodes. You want to be able to make sure that you're robust. One node going down doesn't cause the issues. We're a heavily mobile scale company. We're not even internet scale. Like, take a minute to process that. It's not internet scale, it's mobile scale. Right? People are all over the place and using 2G internet, 3G internet, network connections that are pretty slow. And we are a UX first company. If you look at PhonePe app, I think one of the things that separate us from the rest of the sector is that how nifty we are. It's only possible not just because of the choice of databases, but all the principles we set for ourselves, like async programming, utilization, sharding at multiple levels, fail fast, so on and so forth, right? We move forward. This is kind of the footprint at PhonePe at the moment we run. We run about in 3 sites, 3 on-prem sites. We have 50 plus Aerospike clusters per site, about 160 TB plus data per site, 1 trillion data points. I think I'd go on a limb and say probably one of the largest in the country, Avik. Yeah. I kind of wanted you to take you through multiple workloads, and then we'll talk about a couple of them in detail and then converge with maintenance and the issues around it that we face and how we kind of circumvented a few. And I won't have a request slide. I think I'll slowly squeeze in 1 or 2 as I go along the journey. Edge was the first we started with Aerospike. It was a 3-node cluster, circa 2016. And it was a Auth-not server. It still is an Auth-not server. It's an Auth-not server. It's where all of our JWT tokens get stored. Every request that enters the ingress passes through this edge. Right now, we do about 400,000 QPS on edge on a site with all sub-millisecond read SLA. And in fact, Guru and I were chatting when all of you are talking. I think we are the only ones, at least in the room, who use Aerospike more for read than write. I've seen 75K write to TPS, and I've seen some Airtel mention about write TPS earlier. Ours is a 3:1 split, broadly, I suppose.
Yeah, fast approaching 4:1.
4:1 across this.
Right split.
Yeah. So Edge is pretty simple. Edge is a primary key lookup, about 1 millisecond read SLA. It's important for us. Data is in memory. That's one of the patterns we use for Edge. And then data platform, you have mixed workloads. The AML platform we'll talk about in detail as we go along. And if you sort of look at data platform, right, the models are different. Data is on disk. We use, by the way, we're on Intel shop. We are all on Intel Xeon Gold 6138, all of these are. And for data platform, for example, we run 2 into 1.6 TB NVMEs. I think 1 NVMe disk per node. And the current scale on data platform, we do about 650K QPS and then growing. For this, right, I mean, as opposed to, for example, if you compare it with the middlewares and caches, here we are not tolerant to data losses as it is in the transactional ones. We do multiple things. We do scans, we do range queries, we do about 650K QPS reads. It's about a 17-node cluster, as in 3 clusters of 17 nodes. I think overall, if you compare all of our clusters, we do about a few million QPS on Aerospike. And we have another faceted application, like bunch of other applications like graph data stores, which are application-built graph data stores, where you would play with data models to build multi-read graph data models. And we have a cataloging service that we built atop Aerospike because you can. And I probably would get a boost when you do secondary indexes and then start to talk about nested filters, etc. Typically, what's happened to us is we walk in the corridor, people talk about a problem, and generally the response is, let's just use Aerospike. So I have a bone to pick also. I think what that's kind of done to us is it's made our engineers not understand distributed systems. At the same time, I suppose, helping them build things faster, right? When you talk about transactional systems, right, our checkout layer is completely built atop Aerospike. And we deploy it across sites, unreplicated, of course, because it's transient data store. Our PG layer is backed by Aerospike. It's It's all statement of truth data. It's all statement of record. It's all source of truth data, and we run that in SE mode because you have to have your data be consistent. We'll move, I guess, in the interest of time. We'll get to use cases. We spoke about edge quite a lot. I think from the last time we spoke, right? We have spread ourselves across to multiple sites, right? At the moment, we run from 2 sites live, and we would be running from a 3rd site very, very soon. And it's not bed of roses, really, if you kind of think about it, because the first thing that people kind of think about when you start to show an information architecture like this is, you know what? Why don't you just do active-passive? What is the need to be active-active? Multiple reasons, right? When you start to only think active-passive, you lose the liberty to have the second cluster be live all the time. And it's very, very difficult at your scale, at our scale. I mean, all of you all working at internet scale to move from one DC to another DC without issues. One site to one farm to another farm without issues, with them not being battle tested to begin with, right? So there is no other route if you look at generally anybody who operates at commerce scale to kind of flinch away from being active-active. How we work upon this is, we hash our users or entities that at the ingress, and we make sure that we localize them to a particular DC for the lifespan of their existence on the org, PhonePe, and we could move the entity from one to another as we choose, owing to our replication lag being 0 and data being consistent across the farms. It's our setup, and again, mobile scale, we operate against 2 sites. We have multiple gateways per site. It's not one API gateway. We have about multiple gateways, one for internal, one for external, one for vendors, so on and so forth. The catch is, this is a multi-master setup with bidirectional replication. Over the course of it, I have some performance numbers when we ran multi-site. We'll answer some of the questions there, why we did not choose to go multi-site, but stuck to bidirectional XDR, even in the face of concurrent updates or data collisions inadvertently, which you wouldn't have in multi-site. And we'll also talk about N-star topology as we get to the end of it. The reason why we did choose though is because this is an auth server. We already pin a user, so the conflicts are 0. Because a user is already pinned to a certain DC, you're writing against a faceted key. You don't really collide with the other user on the other DC because the entities are different. There are cases where it won't work. We'll talk about a data platform when we do talk about it. We'll talk about why bidirectional setups kind of can land you into soup and how we have worked around it. See, I think, before this, about 6 years ago, I built a promise engine, right, which was a product engine at one of the other e-commerce companies, which was about doing 200,000 RPS. And I was a Redis fanboy, at least so much so that I kind of contributed to Redis for a while before I think my loyalties have changed. I remember running a 30-node Redis cluster to do a 200K RPS. And 30-node Redis cluster doesn't come for free. You have to have a slave, and you have to have a slave to stand by also, because all of you all who are familiar with Redis, you'd remember if you have to persist data onto disk, right, you have to have save lines configured, and it's a single-threaded one. If you started configuring save lines, there's a context switching that happens, and it has a performance impact on your master. So typically what you do, you have a master, you have a slave, where again slave lines are no save lines are configured, it is the one that's getting promoted to a master. And then you have a third node where you'd use as the backup store. I used to run 30 nodes of that, and in that shop that we ran, it was all maintained by engineers, so it's a nightmare to run it. So in this case, right, I do about 400K QPS and growing. I run about a 12-node Aerospike cluster. This is what really I spoke about when I said capacity planning, right? This is a huge win. I have a bunch of us sitting who actively manage Aerospike here in the org. I don't think they'd want to go back to maintaining a 300-node cluster. But again, is it all roses? No. See, we live in India, right? We are a country which dreads silence more than it dreads chaos. Right? And we are a country where internet speeds are not anything like you would see outside. Our XDR ship latency today at the 99th percentile is 40 milliseconds. So it sort of prohibits us from taking this approach when we sort of scale it to data platforms or aggregations, then we had to go back to n-star topology. I'd run you through the performance benchmarks across during the course of the presentation. We get a fairly decent XDR throughput, 18K, and we ship about 100 MB data per second. So it's a fairly decent throughput for the write scale that we have. And throughput's not the problem, but we have a ping latency of 9 and TCP round trip latency about 18 ms between our sites in Bombay and Bangalore. We're already bottlenecked there. And think about a majority cluster. If you had to set up 3 here, 3 here, your majority writes are always 4. If you're initiating a write from there, you're writing and then coming back and writing, you're dead in water. So we'd have to find out alternatives, and we'll talk about this as we get there. And for this one though, I think it makes sense for us because we're pinned on users, and the entities are different. So long as, the challenge is though is, there are 2 kinds of multi-data center deployment techniques, right? As in from get-go, you're thinking about multi-DC. Let's face it, nobody in India is thinking multi-DC from get-go. Or you're thinking multi-data center and plural sites as you age. When you do that, you cannot migrate your ton of microservices all at once. You'd have to migrate them incrementally. And when you're doing so, if you're talking about Norton server, the keys will have to be available on both sides, because you have to validate every request that comes to every service on every site. Now, if you don't, you will either throw the user away saying you're unauthorized, or the requests are forbidden, and so on and so forth. So for that, again, we had to work around to building retries in the app, trusting the replication latency to be predictable, which has been, 18 ms network latency aside, our 99th XDR latency has always been 40 ms. So it's easier for us to build retries on the app, and then start to build those frameworks where you would curate the requests and then bounce back if at all there were some failures. Right? And we'd take you through data platform use case, and I'd want to spend a reasonable chunk of time talking about XDR and maintenance when we come back from that.
I'm Guruprasad, so I work as a software architect at PhonePe, primarily taking care of the data platform initiative. It's been an immense privilege, like over the last 5 years, to see PhonePe grow from 0 users to 300 million users and still growing. And with that comes a lot of scaling challenges, which actually puts your designs to test. So no design is fully correct until a particular point in time in the future, which may be in the next 3 months or next 6 months. So you'll have to do a lot of it has a way of keeping you on your toes, right? So nothing is humbling like a massive scale. Okay, so I'll give you a brief intro about the data platform at PhonePe. And as you all know, so data platform is all about serving data reliably, structuring, transforming, making it available to all the other systems, in an accurate, consistent, and highly available manner. So all of this has to be done at scale, right? So what are some of the considerations for the data platform? So if you look at it, you can see that it should be capable of handling large volumes of data. We are talking about terabytes to petabytes of data, right, which is continuously growing. Different forms of data, right, persistence and retrieval, of data for the same. So you might have text data, JSON data, blobs, audio, video, scalar, vector, right? All these different types of data. Plus, it has to provide simplified abstractions for data processing. So client integrations have to be simple because a lot of internal systems, external systems are going to rely on the data platform. So it has to, and there's a lot of complexity going on underneath, but it has to be simplified in a manner, that is accessible over REST APIs and stuff, right? Maximize data availability, obviously. So we are all chasing that elusive 5 nines target, target, right? That earlier Leslie spoke about. Strict upper bounds on tail latencies. So yeah, so why do tail latencies matter, for PhonePe? So imagine you are a PhonePe customer and you are trying to make a payment at one of your local supermarkets, right? And there are 10 other people queued behind you, right? So if the P99 or P999 goes high, even for a short burst of time, 30 seconds, if it goes to say, if it increases by as much as 40%, so then you're seeing a huge backlog pile up, head of the line blocking and timeouts, right? So bad customer experience, bad experience for the merchant as well. So the merchant might, like not want to use PhonePe, right? And it be embarrassing on a personal note, for the customer who placed his or her faith in us. So this is something that we deeply care about. And yeah, at Data Platform, we operate one of the largest clusters at PhonePe. So yeah, Aerospike clusters, and Aerospike has helped us achieve all of these, requirements. So the last one is like observability for staleness and failures. So that's a no-brainer. So what are the characteristics of the data platform? So this, the system, systems we have developed, they follow the Lambda architecture, so which combines batch and some elements of streaming and serving. So the aggregates and like summaries of user behavior, like entity behavior, everything is aggregated offline, like using batch jobs, your typical like Spark jobs stuff, right? And then like you have like streaming, you're also computing the same behaviors at real time, like via stream processing pipelines, and then trying to combine the data, right, from t-1 and t, like for an example, and then combining both, and then trying to serve them at scale, like providing like really low read latencies. So it has to be multi-tenant with authentication, authorization, ensure fair usage policy for different tenants. It has to handle different types of data, mixed workloads, single, multiple keyed reads, writes, scans, secondary index scans. It has to operate at a massive scale. We're talking about 300 billion records, 650K like QPS, combined for reads and writes. And like we would like to leverage like the database in both like persistent and ephemeral modes. There are lots of use cases for which we use like Aerospike within PhonePe, yeah, like we tune the cluster differently for different use cases. So I'm not going to go into the depth of the different use cases. I'll just like take one such use case and see how we actually solve the problem with Aerospike and what are the challenges that we face. So yeah, so we have to have long-term retention and stuff and large footprint and all of that. Moving on. Okay, I hope you can see the diagram. So these are the different use cases on the left side. You can see like we use it for fraud detection, ads, personalization, and coupons. So coupons is like, like that's a way of like incentivizing the customer to transact on the platform, right? So all these different use cases require evaluation, right? And evaluation can be done using a combination of like models and rules, right? Handcrafted rules and like machine learning models, right? Everything requires features to be served online, right? So there are online and offline use cases, but I'm going to focus more on the online use case because that too specifically on fraud detection. So we had to build a system from ground up like 5 years back, right? So it was a Herculean task, and the first thing that I noticed, that was great about Aerospike was how accessible it was, and like how easy you could get going, like just by going through the documentation and then like getting started within the same day. So we started with Aerospike, and we are still like on Aerospike after 5 years. So that's a testament to like what things went right, with the choice. So you have an online feature store which has to serve like different kind of data. It's like slow changing facts and fast changing aggregates and geolocation, all of this. So we use different Aerospike clusters for all, like for these use cases. Okay, so this is, like I added more details in the slide. So you can take a look at the SLOs, the systems must like strictly adhere to. So you can see the feature store as these following like query patterns, primary key document lookup, secondary index scans on metadata, right? And for materialization of like features, right? Because everything has to be done prior to serving the read. So that is one design decision that we took, right? So no compute like can happen in the read path. Okay, so even if it comes at the cost of some sort of like consistency loss. Okay, so bulk insertion and updation of documents like via offline path, so as to pre-materialize all the features and then like make them available. So these are the SLOs. P99 reads less than 2 MB will be less than 1 ms, and like P99 writes less than like 5 ms, right? And so with respect to the feature store, like we use Aerospike as a cache on top of HBase. I'll explain why that is the case. So data loss can actually be tolerated and staleness is acceptable there. Okay, these are the read QPS and write QPS. So I'm just going to move on. So we'll cover these use cases more in depth in the next slides. Okay, so with respect to the feature store, this is the data model that we follow. So we use like, the CDTs, right? So key sorted maps with like primitives and a combination of CDTs and blobs, right? We also store the metadata, which helps us like, handle staleness and everything, like, and decide when to refresh the cache and all of that. So HBase is used as a primary store. It's set up on like spinning disks. Aerospike, it's set up on like SSDs. I'll explain why that is the case. It's used as a write-through cache, like so application like manages the data on both the databases. So earlier when we started out, like we put all the data on HBase, right? And like I said, our workload is more skewed towards like reads. So we do somewhat around like, specifically for the feature store use case, we do like 95% reads and like 5% writes in some cases for specific kinds of data. So this is why like it becomes very important to actually pre-materialize all the data and then like reduce the number of disk IOPS, right? So that is why we are actually leveraging Aerospike. So using a multi-tiered system like this helps us reduce the infrastructure cost. So HBase is really good for storing massive amounts of data on commodity hardware, right? But the block cache, as you all know, it's very difficult to tame. You have no control over as an application programmer. So that is where Aerospike comes in, like as a distributed cache, like which is external to HBase, and it can be controlled. Like you can put the kind of data that needs to be served on a cache in Aerospike. Okay, so these are the some of the challenges that we have encountered over the past few years. So sometimes the record sizes get really, really large. It's, there is always something that you can do, like you can actually increase the write block size and stuff, but then it has its own like negative consequences. You are looking at doing more disk IOPS per read, right? So eventually you would like hit performance bottlenecks right on the disk. Right? Also, it has a tendency to choke the bandwidth, network bandwidth between DCs. So we have encountered all that. So one way of solving this problem is to focus more on the data modeling, try and identify the use cases, try to actually optimize. Small optimizations actually make a huge deal of difference when you are storing like 300 billion records. So we have done that. So for example, like we used a custom integer encoding with protobuf, and then like we used the Aerospike compression feature. So this actually reduced our storage cost by more than like 47%. And also as a side effect, more data was being served from the OS page cache. So this actually further brought down our latencies and stuff. So also like records are always growing. Sometimes they are too big to fit. We encounter deserialization issues, and you will have to be on your toes and write scan jobs to make sure that useless data is purged. So this is something that you have to take care of. And disk capacity constraint is something that we keep hitting disk HWMS, the high watermark on disk. So that is another problem. So it turned out to be an operational nightmare, right? So from a maintenance point of view, so you have to make sure that you set up proper alerts and stuff, depending upon your replication factor and tolerances and all of it. And then you might run into slow garbage collection and stuff on flash drives. So you might have to tweak defrag sleep and defrag writes, all of this stuff. So this is another use case for which, in the data platform pod, for which we use leverage Aerospike heavily. So we again use a mixed kind of model here, tall and wide kind of storage. What do I mean by that? So basically, depending upon the particular use case, right? We want to achieve the right kind of balance between read and write amplification. So we store data on multiple records versus a single record. So Aerospike's document API helps there. So again, depending on the use cases. So we use the TTL expiry feature as well for automatic purging of aggregates if they lose relevance over time. Yeah, so we use the single bin namespace for deduplication of writes in the streaming path. So, and these are some of the challenges that we faced. So we have like a very big cluster with a lot of tiny records. So this puts a lot of pressure on memory and disk. So we had to revisit our data model and then like optimize. So sort of like tying in back with the previous slide. And then like we use UDFs heavily because with this cluster because we want to save on the bandwidth and like reduce the number of round trips that we make for reads and writes. CDTs are really great, but then like if you want something more, like as in you want some kind of like custom functionality, right? Say for example, windowing and like sort of like windowing with limits and stuff like that. You may not be able to just like use CDTs and like solve it. So that's why we use like Lua IDFs, but it's very hard to manage. It's very hard to test. And once you deploy UDFs, the cache may not get refreshed and all of that. So we have run into all of that. So that is one thing. So how we ended up solving it was like on the application side, we manage the caches and like try to do a best effort kind of computation. So, and then the curse of the power law, right? So you might like run into read and write hotspots. So read hotspots can be handled on the application side by sharding, but write hotspots require a different kind of strategy. So we ran into this. So like we had to like create a sort of like a Spark streaming pipeline, like and then like let go of the strong consistency guarantees in certain paths for rolling up aggregates and reducing the number of writes. So this typically happens like when we are trying to aggregate on a merchant entity, right? Like sort of like something like Flipkart, right? So the scale at they are on. So we run into write hotspots. And then the mean time between failures for hardware, it actually reduces with increase in cluster sizes. So this is a real problem when you're like deploying Aerospike on-premise, and not just Aerospike, any kind of like database for that matter. So you have to make sure that you like stay cognizant of that. Failure can happen due to like any sort of like error, like a multi-bit error or a disk failure, right? Or it could be due to memory popping out of the socket. We've had all kind of like such instances. So in order to handle that, you have to like make sure that you understand the replication guarantees provided by Aerospike. You have to like enable XDR, right? You have to take like point-in-time backups. So all these features that were discussed like earlier, so will come in handy. So first of all, the SRE have to be prepared. Like they have to have like playbooks which are defined, which can like help them during crisis scenario like this. So it is very real, by the way. In PhonePe, like we might have a node go down like once in every 15 days. So that's the frequency. Okay, and high planned downtime. That is another thing that I wanted to talk about. So when you're doing rolling restarts, I think like Big Basket was also experiencing this problem. So SREs like have to stay up, in the night and then do the rolling restarts. So sometimes it goes on and on for like weeks because like we have such big clusters. So one way to actually solve that is we figured is that like we have to like leverage like fast restarts and then like delay fill migration. This is something that came in handy, for reducing the planned downtime. We are able to reduce it from like days to like hours. So that's it. I'm going to pass the mic to my colleague.
I think we are kind of running out of time, but I'd like to borrow 10-15 minutes of your time if you guys have the energy to sit through. So silence is a yes. That's what my father taught to me. Kind of wanted to give you the idea of scale before we start talking about multi-site deployments in general. Right, we did begin starting to think about actual multi-site deployments. It ran a perf. One of the things I think kind of a request also I have is AS Profiler is great, the benchmark tool that there is, and there's also scalars are extremely configurable. But the problem you run with that is you cannot plug up your own load distribution. Right? It gives you a standard load distribution, you have to adhere to it. Our key sizes are different. Right? In any service that we use Aerospike, in any ecosystem that we use Aerospike, few keys are big, few are small, the workload's mixed. Unless I can generate my load distribution, there's no way I can absolutely tell from Aerospike how much time it's taken. So typically my measure from, measured on the application has got multiple hops, right? We are a Java shop. there's a JVM, there's a connection pool, there is a link blocking queue at the top at the servlet. So we'd have to take that at the pinch of salt, but then, we're not really going beyond 2 milliseconds from the application. So I think we're doing okay there. Just a bit of a context. This is the multi-site setup that we started benchmarking about a year ago, I think around the time of COVID, right? Look at our 99.9. They're on the orders of 40 ms with a throughput of 2500 with concurrency of 64 and with strong consistency enabled, of course. Clearly, this number doesn't work for us, so we'd had to fall back onto either an XDR mesh or onto an N-star site topology. I mean, if you guys are familiar with data center networking, much before we started talking about leaf spine and super spine, people used to do a daisy ring, if you guys are familiar. So it's kind of the first approach that we sort of fell back upon as well. So this is the current setup we run in. Before I go on, how many guys are you from SRE here? Like, who actively manage clusters? How do you like managing a 1,000-node cluster and its upgrades on a monthly basis? It's basically the problem we run into. We're an on-prem shop, right? We had embarked on this mission to upgrade from Xenial to Focal. Before we upgrade to Focal, there's Bionic. Right? So the story continues. And if you sort of recollect the first slide in the presentation that I spoke about, the number of clusters that we have. So it's a real pain problem. More than that, right? The XDR mesh today works like this. Users are pinned to a site. We rely on asynchronous replication. Works when the entities are well defined, like a user or a merchant, where you can say that locality of reference is ensured and then their transactions would happen on a single site. What would you do if you're talking aggregates? We still don't have a good answer for that, except for namespacing the keys into different bins and having application do the heavy lifting. But see, there are also advantages, right? The good part with this is the complexity is generally hidden from the application developers, as opposed to running any other topology where an application developer needs to understand how it's set up and therefore start to fail over from one cluster to another. Here, complexity is hidden and your RTOs are extremely predictable. RTO, for those of you who aren't aware, is recovery time objective. It's the amount of time that you take to move from one farm to another in the case of a disaster. You want to keep them to a minimum. So this helps because all data is located in all places. There's a downside. I mean, obviously a downside. Imagine a site having a 10 gig data, and if you're replicating across all 3 sites, all of them are holding on to 30 gig data. As opposed to your active passive footprint on a 4-site cluster, it gives you a 25% reduction because if you have only 2 replica copies, right? But faster RTOs are a reality. I think again, I'd probably go on a limb and so far say that if at all there was a day where PhonePe were to be down and wallets unavailable, we may probably bring the economy down if the politicians don't, that is. Sorry, mildism got in the way. But see, also the good thing is it's not just storage layer as Aerospike that I'm talking about. You have to understand we also run HBase, we also run Maria, we also run Elasticsearch. There are a lot of reconciliation jobs that run off a data store. And it's easier if your data is contained in one place to be able to do these recons. Otherwise, every site and every cluster that there is, it's the application developer's responsibility to set up reconciliation jobs and reconcile either the pending transactions, so on and so forth. And one good thing, I think one great thing that you get with this approach is, planned migrations. You can actually plan to move from one to another without really flinching an eye, and you can traffic shape the way you want. For example, if you kind of remember earlier in the spends and that philosophical slide where we spoke about recharge and bill pay, we currently shape about 10% of our recharge and bill pay traffic through another site and 90% to another, 100% of ads traffic from the secondary site and 0 from the other. So we could choose to traffic shape the way we want because data exists in all places. Challenges exist, right? I mean, the massive challenge is a data modeling challenge. How do you start to build faceted data models? How do you start to have applications start to do the heavy lifting? It's incredibly tough if you're talking about problems like, imagine a fraud rule which had to be set up against a Visa card. You only had 1,200 transactions. How am I doing this when data is replicating asynchronously between sites? You'd have to over-engineer and start to think about probabilistic models where you say, oh, listen, my threshold is 100, so I have two sides, this is a shaping, so he has 90, he has 10. There's no recovery from that. The errors that you would, there's this thing, right? I mean, distributed systems are great, but convenience never comes ahead of correctness. And that's a huge challenge. And generally with KV stores, you see that, you'd have to be really up to with your data models, because data migrations are difficult. Once you get out with your data model, to be able to migrate that from one to another is a problem. And one of the biggest problems, right, is configuration errors. We are talking about tens of clusters, each cluster having 3 to 10 to 12 nodes. And if I have to have an XDR configuration, one typographical error is all it takes for me to go down. And I know I've read about the XDR proxy that you guys have introduced to sort of minimize that. But again, I'd have to do this in 10 plus clusters. I really quite liked the AMC though. I kind of wanted AMC to evolve the same road that Nambari had for HDP, where I could do write actions from there, configuration management from there. Really, from a database administrator point of view, that would have been quite handy. I kind of don't know the work that you're doing with Amazon, but or AWS in general, would like for them to see the work translate into on-prem setups. Because I'm not too sure, other than a handful of us, how many of them are even running on-prem setups, but it's extremely handy. Right? And concurrent writes we spoke about, aggregations we spoke about, bin shipping is a problem. There's no diff shipping, right, at the moment, so we'd have to be really conscious about the bin sizes. Otherwise, we choke the network, and we have done it a couple times already. With CDTs and bin sizes being huge and liberally extending the 1 MB to be whatever we want to be, and then coming back to realize that, oh, shoot, there's a problem, and reworking on the data model. And active footprint growth is the one that I was talking about when I said 10 GB data across 3 sites is spaced, practically 30 GB for all of them. The other problem is, a network link failure. No, we don't quite know how to get away from that if it grows from more than 2 sites into 3 or 4 or whatever, because, data is being replicated as a daisy chain. It quite becomes a partition. How do you recover from that point? It's where I don't even know how do we recover. We're still kind of figuring out how do we recover from that point on. There are various strategies, right? We'll look at one such when we talk about N-star topology. Other thing we were thinking about is should we limit to 2 sites, but that's sort of waste of an infra footprint, right? You won't be able to sleep peacefully at night. Data migrations are a challenge. Guru sort of touched upon it. I think Nanda Kishore spoke about it, right? Generally, adding a new cluster is a challenge if you have secondary indexes at the moment. We've even the edge cluster, every time we had to add a node, it's about an hour and a half to add a node to the existing cluster. Thankfully, we don't do it often. The last time we added a node was 8 months ago, and I think we run at a 35-40% watermark. So we're good for a reasonable future. So this is the topology that we're sort of now flirting with, right, to see if this works or doesn't work. N-site replication guarantees correctness, at least, data is consistent. Sure, it's not available at all places at once and your RTO takes a hit, but your active footprint reduces, right? For example, if you're operating with a replication factor of 2 on a 3-site setup, you won't obviously see it. On a 4-site setup, your footprint comes down by 25% because you only have 2 copies. And imagine in the earlier one, if you have a 30 gig cluster, to recover a 30 gig, versus recovering 10 gig when an instance goes down. Obviously, the cost of maintenance comes down. Recovery is faster. Predictable data layer migrations. What do I mean by that? Move from one place to another. For example, move from a storage layer 1 to a storage layer 1 passive without compromising on the integrity of data. Here is where the problem is also. How do you move, really? So much easier to say, no? It's so much easier to be a cricket commentator and talk about a shot, but then really play on the ground. How do you move it? How do you move from one place to another without database proxies, right? If you think about any other data store, right, that you are using an HBase, using a Maria, wherever, you set up circular replication, it's great. You set up one master, n passives, that's great. How do you move from one to another? You'd have to start to implement custom heartbeats. You have to have a HA proxy or something on top of it, see if it's healthy, and then move from one to another. Would like it if it's primitive. Would like it if we can move from one to another primitively without, for that, you'd have to understand storage layer passives as slaves and assign priority to slaves and then start to move like that. It'd be nice to have it. It reduces a lot of boilerplate that we'd otherwise end up writing in the name of database proxies. I'm pretty sure every big organization out there is sort of flirting with this problem. The problem, setup errors are a minimum, at least, because when you're setting up for the first time, if your passives go down or if passives are incorrectly set up, you're not really fretting, as opposed to the architecture like this, where every node will have to be up all the time. The catch, however, is these are not live clusters. Till the time you route traffic to these clusters, you wouldn't quite know if they're performing the same way you want it to be. There could be network, there could be firewall. You know what, a couple weeks ago, I think we reported an issue to Aerospike saying that the ad hoc latency, there was an ad hoc latency of 43 seconds every now and then, turned out to be a GC issue on a Java shop. Right? The point I'm kind of trying to draw attention to is it's very difficult when you don't have these as live clusters. You don't know what firewall is acting between these two. You don't know what is the hit you're taking. So it's on you then to move from one side to another continuously. And trust me, it's a nightmare when you're talking about 100 plus clusters. And your RTO increases. It's not just about storage layer, right? I mean, companies are frugal. If you start to set up active and passive like this, there's no way in universe, at least in whatever universe is that Thanos won, you're not going to have your applications deployed because your SRE is going to save cost. Why do I set up applications when I'm not routing traffic? And how do you set up applications when a disaster happens? Right? No container orchestration framework, no deployment framework can deploy 100 microservices parallelly. What do you do in those cases? You're actually incurring costs here by setting up. It's not a problem specific to Aerospike. I think it's a problem specific to the need of database proxies. Right? As administrators, as developers, I think database proxies are the real need of the hour. So I think for the last decade and a half, from the time HBase has come out, right, we've always sort of been internally working on database proxies. Every company you ask, they have a database proxy. I think the need is real. Application modeling challenges continue to exist. Spoke about aggregate, spoke about faceting, and uncontrolled inter-site communication. It's an actually important point. Like I said, we are not moving the entire ecosystem from one side to another. We are moving service by service. If you replicate like this, imagine a service A residing in site 1, service B residing in site 2. How are they communicating? Sure, you'll write an amazing service discovery framework, etc. But how are you predictably communicating between your DCs? Your bandwidth might go for a DOS. Developers may make mistakes. How are you retreating from there? We don't know. I'm not really talking about log sequence numbers and conflict groups in a way Aurora talks about it, or in a way I think Spanner sets it up. It's not easy, right? It's not easy to have linearizable writes when you're talking about a distributed or an asynchronous application more than distributed, right? It's extremely difficult. How do you guarantee write order in an asynchronous application? We don't know. I think probably you version them, assign a timestamp, but then applications will still have to do the same thing because you're not really conflicting the writes. So instead of overriding a 2 with a 3 on both sides against a key K1, you have a K1 2 V1, K1 3 V2. Then what do you do? It's an application problem again. So I think, again, the need for database proxies, I can't emphasize on that enough. So you could migrate from one to another in the face of an outage. Not so much to conclude, to leave you with a bunch of thoughts. I think what's really helped us is, I think 3 years ago, Burjan said this, 2 years ago, I said this, I'll say this again, we sleep peacefully at night. So thank you. We don't have a... the problem, however, is, I have a couple minutes, Avik, if it's all right. Just 2 minutes. Yeah, we'll do that. See, the couple of problems that we have is, Aerospike alerting is a monitoring framework that Aerospike has, or the attributes that you have around are extremely detailed. But also at the same time, they're one too many. Right? I mean, as traditional SREs, people are used to only measuring disk sizes and CPU and memory. They're not used to measuring watermarks. They're not used to measuring disk write percentages, stop writes, etc. But you'd have to be careful about them. Otherwise, you run into cluster issues and you're doing migrations. If you don't take care of watermarks, you have downtimes. You have to be really mindful of it. Bunch of the things we've spoken about along the course of the presentation, I think, again, to leave you with a thought, I'd really like to see AMC reimagined, make configuration management easier for SRE, make configuration management less error prone, and be able to do write actions from it as opposed to just being a read. I know the Prometheus Grafana stack. I could do that. I mean, even relaying the metrics via Telegraph to OpenTSDB. But then I couldn't, for example, take a node out of rotation from my UI. SSH is great, but I really don't want my engineers to sit and do CSS checks and prod 10 boxes and then make mistakes. So yeah, that's about it. So overall, it's been great. I hope to see this continue like this. Probably when we speak next time, we would have set up Aerospike across sites for pretty much everything we have, and we'll have more learnings. Yeah, questions we can take outside. More on distributed databases and consensus we can take now. About PhonePe, I suppose we can talk whenever we meet. Thank you very much.